So before we go on to a new quadratic form and some other tasks, I want to revisit the general form from the last video. And I want to mention kind of a formula or a shortcut to finding the vertex. So if you're given the general form of a quadratic, you can complete the square, and that's fine. Completing the square is a skill you will need every now and then in your math courses, so it's worth reviewing that. However, there's a formula for the vertex. So the vertex will say, let's pick new letters just so we have something to use in our equations. Let's say the vertex is hk. Well, h is just negative b over 2a. So whatever b and a are, let's say a was 2 and b was 3, you'd say negative 3 over 2 times a, which was 2 in my example. And once you have h, that's the x value of the vertex. In order to find k, you just plug h back into your function. So if you got, let's say h was 2, you could just plug 2 in for x and see what you get for k. So here are the formulas. This comes from completing a square. You might, if you go back to the previous video, might see this pattern, negative b over 2a, but this is the formula for completing the square. So let's do one more example. This one's going to be a little bit more involved. So let's go ahead and let's graph the function f of x equals, let's see, 2x squared plus 3x minus 14. Okay, now once again, we need to remember our y-intercept, our x-intercepts if they exist, and also the vertex. Okay, so let's go ahead and get the y-intercept first. That's usually the easiest when you're in general form. The y-intercept is just right there. So it's going to be the point 0, negative 14. You could get that if you plug 0 in for x, the first two terms just go away and you're left with negative 14. Let's do the x-intercepts. So we have to set the entire function equal to 0. Now at first glance this might not look factorable, but what you have to do is you take a times c, that's negative 28. And so now we need two numbers that multiply to negative 28 and then add up to 3. So hopefully we can find something. 28 and 1 won't work, 14 and 2 won't work, but 7 and then minus 4 I think they both do work. So 7 and minus 4. Now there's a couple different methods for doing this, which I reviewed in a previous video. So let's go ahead and just kind of do it. Plus 7, and then x minus 2. I believe that works. Negative 14 plus 7 minus 4. Yep, that works. So what I did was I took 2x squared, I did plus 7x minus 4x minus 14, and then I factored by grouping, and you end up with that as your final answer. Okay, so solving for x, we end up with x equals negative 7 over 2 and x equals 2. So my two x-intercepts are negative 7 over 2 comma 0 and 2 comma 0. All right, now the last step is to find the vertex, and let's use our new handy dandy formula. So let's go ahead and say h is negative b over 2a, so negative b, that would be negative 3 over 2 times a, so that's negative 3/4. So we do have a fraction, but at least that's quite a bit easier than completing the square. And now what we have to do, in order to figure out the k portion, we're just going to plug the x value we found back into the function f. And I'm going to go ahead and use a calculator to do this, so you can't see it, but it's 2 times negative 3 over 4 squared plus 3 times negative 3 over 4 minus 14, and I end up with negative 121 over 8. That's going to be kind of hard to graph though, so I'm going to actually write this down as its decimal approximation, negative 15.1. Same with this one, just so it's a little bit easier to graph. And now we can actually set everything up. Set up our x and y axis, x, y. Let me go ahead and put some points down. I'm going to need 2. Negative 7 over 2 is about negative 3.5. I'm going to need to get all the way down to about negative 15. Let's go ahead and start graphing some points. X-intercepts are 2 and negative 3.5. The y-intercept was negative 14, so probably right about there. And then my vertex is maybe around there. And the axis of symmetry, if I ask for this. So there we have it. All right, so once again, this was a little bit more involved because we had to do some extra factoring stuff. It was a little bit harder to do that. The vertex had some fractions in it. But if you stick with it, it turns into, I mean, the steps are all pretty straightforward as long as you don't worry about the numbers too much. Great. So we're now done with the general form. I would say the general form kind of looks the nicest, but overall it's the least useful. So let's talk now about vertex form, and I've already alluded to this in the previous video. But here is the vertex form. So if I have a function f of x, I can write it as a. So it's the same leading term, leading coefficient as we had in the last one. And then I'm going to write x minus h squared plus k. The reason the vertex form is so nice, so again, a is the same a as before. It's the leading coefficient. And hk is the vertex. I want to point out though, h changes signs because remember this is a translation to the right or left. So x translations always happen the opposite of what we would expect. So if it's x plus 2, we're actually going left 2. If it's x minus 2, we're actually going to the right 2. So let's go ahead and take a quick look at an example. Let's say we had to graph the function, oh, I don't want to use a, sorry about that. Let's graph the function q of x equals 1/4 x plus 1 squared, and then let's do minus 4. Actually, I think I'm going to change that to a plus 4, and I'm going to change this to a negative 1/4. All right, so once again, we still need the y-intercept, the x-intercepts, and the vertex. So let's go ahead and start working on those. For the y-intercept, we set x equal to 0 no matter what. And we end up with negative 1/4 times 0 plus 1 squared plus 4. You can plug it into a calculator or use PEMDAS. You should get 3 3/4. Or another way to write this would be 19 over 4 or 3.75. Okay, so there is my y-intercept. I'll use the decimal approximate, well not, I'll use the decimal answer here so it's easier to graph. For the x-intercepts, we have to set the function equal to 0. Now, it kind of looks like we'll have to expand out that x plus 1 squared, but there's actually a better way to do this. So let's go ahead and subtract 4 from both sides so that I end up with negative 4 equals negative 1/4 x plus 1 squared. Now I'll divide both sides by that negative 1/4, which is the same as just, we're going to multiply both sides by negative 4 so that these cancel out. And so now I end up with 16, positive 16 equals x plus 1 squared. If I take the square root of both sides, that'll get rid of that squared. So I'm left with plus or minus 4 equals x plus 1. And now I'm going to subtract 1 from both sides. Now this is a good point. Since we have that plus or minus, we actually have 4 minus 1, which is 3, and we have negative 4 minus 1, which is negative 5. So there are our two x-intercepts. We have the point 3, 0, and we have the point negative 5, 0. Okay, so the x-intercepts are maybe a little bit more work, maybe not. It's kind of up to you than factoring in the general form. So if you wanted, you could convert to the general form and then factor. It's up to you how you solve these. And so finally, the vertex is the most straightforward when we're in vertex form because we just go back and look. Notice we have x plus 1 and then plus 4, so the vertex is going to be negative 1, 4. Remember, because x plus 1 actually moves left 1 and then up 4. Okay, so we're ready to graph. We have all of the pieces that we need. X, Y, I'm going to need to go up to 3, down to 5. I'm going to need to have 1, 2, 3, 4. And then what was the y-intercept? 3.75. Okay, we have that graphed. Here we go. There's the vertex, roughly. There's the y-intercept. You go to negative 5, 3, and so my graph actually opens down because A was negative. And because we haven't done this since the first problem up there, let's go back and do domain and range for this one. So the domain is always going to be all real numbers for quadratics. The range, in this case, we're going from negative infinity up to 4. Notice that my maximum y value is 4, and then we have everything down there. So it kind of looks like it should be 4 to negative infinity, but that really doesn't make sense because you want to put the smaller number first. And negative infinity is definitely smaller than 4. All right. So now we've kind of completed everything we wanted with graphing. What I want to focus now on is more algebraic stuff. So what I want to talk about is converting, which I talked a little bit about before. So let's just say you're given some function or some equation. And this is a skill you already have. You all have good algebraic manipulation skills. But just to kind of give you an example of something you might have to see, you might have to do. Let's say I had given you this problem. Convert the vertex form to general form. Well, following PEMDAS, we first are going to focus on the x minus 1 squared because that is the exponent component. There's nothing we can do in the parentheses, so let's go ahead and do x minus 1 squared. So it'll be x minus 2 squared. Now we have to multiply, so I'm going to distribute that 3. And then finally, my final equation looks like this, 3x squared minus 12x minus 4. So if you were to convert, like I mentioned before, this is how you could do it. It doesn't take too much work to do as long as you're careful with your PEMDASing. All right, so this video is about at time, so let's go ahead and end there.